part of the video, we discussed the use of exponents and the use of bases. And I told you that everything you've been seeing, everything you've worked with, are actually bases and powers. If you've seen 500 or $500, 500 naira, it's simply 500 raised to the power of 1. The 1, which is the power, may not be written all the time. And now we discussed 3 rules. I discussed 3 basic principles. I said that if we have the bases to be the same and we multiply them, we have the rule says that we should multiply the powers. We also said if likewise we have this dividing, we can subtract the powers, and that led us to discover that any number raised to the power of 0 except 0 itself will give us 1. And we also talked about cases where we multiply this and that give us a raised to the power mn. So you can always check the last video to understand this better. So what we want to discuss are other rules. Now think of it, the powers are not always going to be this nice. They are all just nice looking powers. What if the power is negative? Think about that. What if the power is negative? For instance, so we're talking about the 5th rule now. So what if we have a raised to the power of minus n? What do we do in such a case? The power is negative. What you're seeing here is just a follow-up of the 3rd rule. What you actually see here is the same thing as a raised to the power of 0 minus n. So minus n is actually 0 minus n. And if we were to follow this rule, just look at this. If we were to follow this rule, we say that this will be n, this will be 0, for this to be 0 minus n. So that simply means that this can be written as a raised to the power of 0 over a raised to the power of n. This actually gives you this. So a raised to the power of 0 divided, because this is 0 minus n. And we know already that a raised to the power of 0 is 1. So this is 1, and this is a raised to the power of n. So that gives us the next rule. And the next rule is what you always think of every time you are prepared, with a smile on your face. And that rule says that a raised to the power of 0 is actually 1 over a raised to the power of n. So it's a very beautiful rule. So if we see something like 3 raised to the power of minus 2, there is no need to fear. All you need to know is that that is 1, since because of the negative power, divided by 3 raised to the power of 2, and that is 1 over 9. Beautiful. Why is this 9? Because that is 3 raised to the power of 2, and that is 3 times 3. You're multiplying 3 by itself twice. So, beautiful rule, but it won't be this nice all the time. So we need to be very candid with that. Sometimes it may be a fraction. What if we have a over b raised to the power of a negative number? What will that give us? I'm going to give you a shortcut to that. The shortcut to that is that this will simply give you b over a. Now the power becomes positive. So you see, this is a over b, and there's a reciprocal, an inversion of the fraction. A of b over a raised to the power of n, now positive. But somebody will ask, okay, I understand that. I understand that now 2 over 3 raised to the power of minus 3 is going to give me 3 over 2 raised to the power of 3 now. And by the rule I talked about in the first video, this is going to be 3 raised to the power of 3 over 2 raised to the power of 3, and this 3 raised to the power of 3 is 3 times 3 times 3, and that is 27, and this is going to be 8 if we use the same method of multiplicity. But the candid question is that how did this become this? It is obvious. It's obvious because this is simply a raised to the power of minus n over b raised to the power of minus n. That is if we are to share the powers as we talked about in the first video. So this is a raised to the power of minus n and b raised to the power of minus n. And we know very well that if we are to follow this rule, which we all understood, this is going to be 1 all over a raised to the power of n divided, so this is this, divided by b raised to the power of minus n, which is 1 all over b raised to the power of n. And we know in basic mathematics that if we are to change this division to multiplication, we should turn this upside down. So it's a basic math we all knew in our primary school or in our grade 2 or 3. So if we change this to multiplication, we are going to have 1 over a raised to the power of n times b raised to the power of n over 1, and that is going to give us this times this is going to be b raised to the power of n, and this times this is going to be a raised to the power of n. So we have this giving us that. So that is what you should think about with a surprise. So That is a rule, and that's what it says. So the next rule I want to discuss is very interesting, and the rule simply says, what if, I told you the powers may not be that nice all the time. What if the power is a fraction? We talked about the case where the power is negative. What if the power is a fraction or a decimal? So what if we have something like e raised to the power of m over n? So in this case, the power is not just an integer or it's just a fraction. So what do we do? In the representation, what you actually see here is something like this. So let me just make you see that. Yes, this is what you're seeing. You remember this rule. Please, you remember this rule where we have to multiply powers. So if we have to multiply this times this, that's going to be m times 1 over n. m times 1 over n is actually m times 1, which is n all over n. m over n. So this is what we actually have. So all we need to do is to represent this. This is 1 over n, which is a fraction. So we are going to have a sword, and we are going to have this. So you ask me, how am I coming in with this? That is very important to note. If you have b raised to the power of 1 over 2, take note that this 1 over 2 is just the same thing. It's just the same thing as the square root of b. The square root of b. So square root, we usually do not put the 2 there. So if I have b raised to the power of 1 over 3, that is going to give me a cube root. This is a cube root of b. But this is, and all this can be very scary. So that's very scary. See, friend is not happy. So I will show you a better way to handle this. How do we handle cases like this? Let us have a question in mind. So for instance, we are having 16 raised to the power of 3 over 4. I want to show you a better method rather than going this way. 16 raised to the power of 3 over 4 will simply give us a very beautiful value. So this will give you 16 is actually 2 raised to the power of 4. So we can go over that. 16 actually 2 raised to the power of 4. 16 is 2 times 2 times 2 times 2. That is in 4 places. So I can write 16 as this. And I can now apply this rule to give me 2 times, so 4 times this. And this will cancel this. And what I have left, so if 4 cancels 4, or we can say 4 times 3, 12 over 4, that is 3. Anyhow, it's comfortable with. You can see that 2 raised to the power of 3 is the same thing as 8. So this is another method you can apply rather than following this route. So these are the beautiful rules that we can apply in solving a lot of problems. So in the next series, I'm going to be talking about how to solve indicial equations. This actually leads to equations. So how do we handle such equations? So thank you, and watch out for the next video.